Hey guys, hope all are fine. So now we will see the working of a NPN transistor. Okay. So I have taken bc547. Okay, this bc547 is an NPN transistor. So first we will see this symbol. This is the symbol of an NPN transistor. So always in NPN transistor the current will be flowing from collector. This is your collector, this is your base, and this is your emitter. Okay, so the current will be flowing from collector through base through your emitter. Okay, this is how the NPN transistor works. So we will see this we will see the working of this transistor with a practical circuit. Before getting into practical, we will draw the circuit and then we will get into our practical. Okay, so first let me show you a circuit to switch on an LED with the help of a transistor. So now we are going to use this transistor as a switch. Okay, so this transistor can be used either as a switch or as a amplifier. Okay, see, amplifier is simple, which means this transistor can be switched on or biased with very less base current. See, if you give very small amount of base current, this transistor will conduct, so that high current will be flowing from your collector to your emitter. So that is why it is called, it is acting as an amplifier. Okay, so we will understand that in our circuit also. So first we will take a, usually we are going to take a battery. Okay, the battery, 9-volt battery. Fine. So connect it to the collector. Always in NPN transistor, connect your supply to your collector. This is your collector. Okay, that is the 9-volt positive. You connect it to your collector, and this is your base. In the emitter, connect a resistor and connect a diode. I mean LED. Okay, this is your ground. Ground is nothing but connect the negative of your battery to this end. Okay, this is your LED. This is your resistor. You can take any resistor. Normally you can take 1K. Okay, now what is the working principle of this transistor? Whenever this transistor is provided with a small base current, this transistor will be biased. Biased means will be activated, so that this current from the 9-volt battery will flow through the collector, base, emitter, through this resistor, through this LED, and reach the ground, so that the circuit is closed, so this LED will glow. That's all. This is the working principle. Okay, see, let me draw the circuit once. Give you the explanation once again. So I am using a resistor here. Okay, so this can also be 1K. I'll tell you why I am using 1K. See, very small current is required at the base to make this transistor switch on. Okay, so that is why we are connecting a resistor in series. Okay, so which means that from this 9-volt supply, a small amount of current will be flowing to your base, so that the moment this base receives current, the junction between collector and emitter will be breaked, so that the current from 9-volt will flow through the collector, base, emitter, and it will flow through the resistors. Again, some current will be reduced, and it will flow through the LED and reach the ground, so that they reach the negative, so that the circuit is closed. Can you see this? The circuit is closed from positive to negative. Since the circuit is closed from positive to negative, and an LED is connected, this LED will glow. In case, if you now just imagine, I am just connecting a switch here. Okay, now this is a switch. Now this switch is open. So now since the switch is open, there is no current flow to your base. Since there is no current flow to your base, this transistor will not be biased. When this transistor is not biased, the junction between your collector and emitter will not be breaked, which means there is no path for the current to flow from your collector, that is your 9-volt supply collector at the collector to your ground. So your LED will not glow. circuit. So we have our battery and this is our NPN transistor. This is a bc547. So always remember guys, in bc547 it is from the left hand side, collector, base and emitter, CBE. You can remember it as CBE. Okay, so collector, base and emitter. From left hand side, CBE, collector, base, emitter. Okay, so connect your NPN transistor to your breadboard. So connect your supply. I have given the supply to the base, I mean collector. Okay, so as we have seen in the circuit diagram, provide positive supply to your collector. Okay, and then connect a supply to your base through a resistor, which means, see, we have taken a resistor. Usually you can take a high value resistor because very less current is enough to bias this transistor. Okay, so I have taken a resistor and connected it to the base. So this resistor will make sure that very less current will be flowing to your base. Okay, so now we have given the supply, we have given biasing signal to your base, and now we have to connect an LED. So connect an LED at any one of the point. Now from the emitter collect your LED. See, collector is connected with the supply and your base is connected with your supply through a resistor, so that current flows to your base, and emitter is connected to your LED in series with an resistor, which means we are limiting the current flowing through the LED, so we are using a resistor. That's all. Okay, so I have connected anode and cathode I connected to the ground. Now the moment if you connect your negative pin, your LED will glow. As you can see here, the LED glows. Okay, which means now your transistor is on. Okay, now we need not take off your supply to cut off the to switch off the LED. The moment if you remove this base, see, I am removing the base from your transistor. See, the base is removed, so the transistor is switched off, which means no current flows from your collector to emitter. So we have connected LED in your emitter, so no current flows, so LED is switched off. The moment I connect the base, the transistor get biased and current flows from collector to your emitter, so the LED glows.